video, you will be understanding the problem statement of the footing design project. You are going to design a mat footing for a building. You will use the parameters obtained from the tall building, designed in our course on tall building design. The process of analyzing the loads acting on the footing, and thus arriving at the problem statement, is being illustrated. The students who have not done the course on tall building design, the problem statement will be explained in its completeness, separately. Just proceed with the initial part of this video, and you will arrive at the problem statement. For those of you who have done the final project on tall buildings, open the project in the eTabs software. Open the file of the final project in eTabs. Once the file is opened, go to the Model Explorer and locate the Analysis option. Please note, the Analysis option might not be displayed if your model is unlocked. In that case, run Analysis on the building model again. Expand the Analysis option, and then Results option. Then under Frame Results, double-click on the Column Forces option. A table is displayed, listing the axial forces and moments through each column. You need the forces applied on the bottommost story. So right-click on the heading, Story, and select Story 1, to filter the results of Story 1. Now in Story 1, the loads and moments for different load patterns and combinations are displayed. Right-click on the Load Case/Combination option, and select the dead load, then click on the heading, to filter out the dead load results. For each column, there are 3 values displayed. These values are at different locations of the column. You need the loads at the bottom point, that is at 0 meters. So right-click on the Station option and choose Sort Ascending. The axial load values, at 0 meters distance of each column, will be displayed at the top. And accordingly, the axial force for the dead load are displayed. Stretch the table upwards to view all the results. Thus you will get the dead loads, and the live loads can also be checked by changing the option. First we'll check the dead loads, so change the Load Case option to Dead. Now the columns are named as C1, C2, C3, etc. So how do you know which column is named what? In the Model Explorer, click on the Detailing tab. The Detailing tab is empty, so go to the Detailing menu, and click on Start Detailing. Once detailing is complete, expand the options as shown, and select the Concrete Column Layout Story 1 option. The resulting plan shown in the software displays the name of each column. Thus the column at the bottom right is C1, and as you go up, the columns are C2, C3, C4. Similarly for the next row, the bottom column is C5, and they are numbered serially in the same way, up to the 16th column, C16. In this way you can find the dead and live load through each column at station 0 meters. Now how do you know the dimension of each of these columns? In the Model Explorer, select the Model tab. Expand the Structural Objects option, and go to Story 1. Expand the Columns option, and each of the columns, from C1 to C16 are listed. Double-click on each column to find the dimensions. C1 is a 500 by 500 mm dimension. Similarly, C2, C3, C4, C5 columns are of 500 by 500 mm dimension. Again, C6 and C7 are of 600 by 600 mm dimension. After checking all the columns, it has been found that the 16 columns are of 2 different dimensions, 500 by 500 millimeters, and 600 by 600 millimeters. All the dimensions are being listed ahead. Also, you need to know the materials in these columns. Go to Define, Section Properties, and click on Frame Sections. Select the C500 by 500 column, and click on Modify/Show Property. The material is M40, and the rebar is HYS D500. The C600 by 600 column also has the same materials. So based on the information gathered from here, we will arrive at the problem statement, which will be explained now. This is the plan of the building, for which you have to design a mat footing. There are 16 columns in total, which are arranged 6 meters apart, in both X and Y. As explained, the column names C1, C2, C3, etc. are shown, up to C16. You have to consider a safe bearing capacity of 300 kilonewtons per meter square, and an allowable settlement of 1 centimeter. The data obtained from the building project in E-tabs is being displayed in the table. The column name, along with the dimensions, the dead and live loads through each of them, and the materials, are being displayed. Please note that C6, C7, C10, and C11 columns have a dimension of 600 by 600. Keep a note of this data, as you will be needing it to design the footing in safe. The SBC of the soil in this case is 300 kilonewtons per meter square. Hence the subgrade modulus is 3 times 10 to the power 4. The base slab of the building is 18 meters, in both X and Y. So considering 18 meters length, the design strip width is 4.5 meters. But the thing is, there is no concrete provision for the strip width, and you can allow a lesser width. In this project, we will take a strip width of 4 meters. Now the plan shown is the plan of the building. The mat footing underneath will be extended on all sides to cover the corner columns. Let us design a footing, which is extended 2 meters on all sides of the building plan. Then the actual length and breadth of the mat footing will be 22 meters. You will now start the project in the SAFE software, which you will learn in the next video. Thanks for watching. Welcome to the second video on Foundation Design for a Building. In this video, you will define the properties and draw the elements for the mat footing design project. Open the SAFE software. Select New Model from the File menu. Change the design code to IS456. Check that the default units in metric. If not, then change them by clicking on Modify/Show. In the design preferences, change the clear cover to 50 millimeters, in both top and bottom. Let us take a preferred bar size of 22 millimeters here. Click on OK. Then choose the grid only option. You will first draw the slab of the building plan, and then extend equally on all sides to make the footing. The building slab is of 18 by 18 m dimension. Note that you will draw the building slab of 18 meters by 18 meters dimension with the grid. You will then extend it for the mat footing slab later. Thus, using 1 meter spaced grid lines, you will need 19 grid lines in both X and Y directions. Thus, for both X and Y, enter number of grid lines is 19, and spacing is 1 meter. Click on OK. The grid of 18 meters by 18 meters dimension had been formed. Now you will be defining the required properties. Go to Define, and select Materials. Add the M40 concrete, and the HYS D500 rebar, by entering the standard values as displayed. Make sure you are entering the correct values, and property type. Once both the materials are added, click on OK. Now you will define the elements with these materials. Go to Slab Properties in the Define menu. Add the property for the mat footing. We will use the same materials for the footing as the columns. Change the slab material to M40 and the thickness to 500 millimeters. In the slab type, you may change the type to mat. Click on OK, and the footing property has been defined. Now go to the Column Properties option in the Define menu. Although there are 16 columns, they are only 2 different types, so you have to define only 2 column properties. Add 1 column of M40 material and dimensions 500 by 500 millimeters, and another column of 600 by 600 millimeters dimension. Once the 2 columns are added, click on OK to exit the column properties. Then go to the Soil Subgrade Properties in the Define menu. Here the subgrade modulus is 3 times 10 to the power of 4. So change the subgrade modulus of the listed soil property to 3e plus 4. Click on OK to exit. Now check the load patterns, load cases, and add the 2 load combinations, one for ultimate load, and one for service load. All the required properties have been defined. You will now proceed with the drawing of the elements. Go to the Draw menu, and select the option Draw Slab/Areas. Check that the mat footing property is chosen. Now start by clicking on one corner of the grid system, and click on the other corners 18 meters apart, one by one. Then go back and click on the first point, to close the figure. Once the slab is drawn, close the box, and press Escape on your keyboard. This is the slab of the building plan dimension. You will now extend this slab by 2 meters on all sides. Click once inside the area of the footing to select it. Make sure you have pressed Escape before selecting the footing area. Verify the selection in the bottom left corner. After the footing is selected, go to the Edit menu, choose Edit Areas, and select the option Expand/Shrink Areas. Enter the offset value of 2 meters, which will be 2000 in millimeters, and click on OK. The slab has been expanded by 2 meters on all sides. This is the actual area of the footing. Now you will place the columns on the footing. Select the Draw Columns option in the Draw menu. Change the property below to None, and the property above to column 500 by 500. Change the height below to 0, and the height above to 2 meters. Now the column 500 by 500 property is for all the columns, except C6, C7, C10, and C11. So place this column in all the positions except these 4. The dimension lines, as well the grids, will guide you in locating the column positions. Once you have completed drawing the columns of 500 by 500 dimensions, change the property above to column 600 by 600. Then place the 4 columns, C6, C7, C10, and C11. Press Escape after you have completed drawing all the columns. Now you will draw the design strips on the footing. Go to Draw, and select Draw Design Strips. Change the design strip width to 4 meters. For the strip layer A, draw the 4 design strips in the X direction, through the column centers. Right-click outside, after drawing each strip. After drawing the design strip layers A, change the strip layer to B. And again draw the 4 design strips in the Y direction. Once you have completed drawing the design strips, press Escape on your keyboard. You have drawn all the elements in the footing model. In the next video, you will assign the properties and loads to the footing model. Thanks for watching.